All right, here is our third problem from exam 1, and this is our kinematics problem. So this was the one where we had the guy who was kicking a ball from point A right here, and the initial velocity there was 10 meters per second. You can see our angle was 30 degrees with the horizontal. And at point B, he reached the max height, which is going to be indicated with H. And then finally, the ball is going to fall back down at point C. Now, what we want to do is we want to find the range. Now, the range is going to go from A all the way to C. All right, so I want to find that distance. And then I also want to find the speed at which the ball strikes the ground. So I want to find the velocity right here when the ball hits the ground. All right, so remember, it's not going to be 0. It doesn't go to 0 until it actually impacts the ground and has all the forces and everything acting on it. So we just want it right when it hits the ground. Okay, so that's what we're going to do. Now, this is just a projectile problem. So first thing I always do is I write out my different sets of information. All right, so let's look. Let's do the x direction first. So our initial x velocity is VAX. You can see we're at a 30-degree angle here. Magnitude of velocity was 10. So VAX then is going to be 10 cosine 30. All right, and that's going to be positive. And our x at point A is going to be 0 because I'm using this right here as point A as my reference point. So we're going to start at 0, and then what about my acceleration in the x direction? Well, I don't have anything there, so that's going to be 0. And then my final displacement in the x direction will be at point C, so let's call it xc. That's going to be the unknown r. Okay. Now let's do the same thing for y. So VAY is my initial velocity in the y direction, so that's going to be the 10 sine 30. It's going up, so that's positive. And let's do the y displacement at point A. So where are we initially? If this is my reference point at A, YA is going to be 0. What about my acceleration in the y direction? That's going to be a negative 9.81 from gravity. Negative because it's going down. I'm assuming up is positive y. All right, so if you want, you can write that out there. So to the right is positive, up is positive. And then finally, I need YC. So this would be my final y location. So that's going to be 0 because I'm measuring from this x-axis, essentially. So these are the data points that I have. And I want to find r and the velocity at C. So first thing I'm going to do is I'm going to look and see if I can find r. So I'm going to look at the range where we go from A to C. All right, so let's do that first. Now in the x direction, since the acceleration is 0, we really only have our one equation that we can use. All right, and that's our final displacement equals the initial plus the initial velocity times t plus 1/2 axt squared. All right, so for us, the acceleration is 0, so that goes away. And then let's fill in the rest. All right, so our final displacement was xc, so that's r. The initial displacement was xa, so it's going to be 0. And then I have my initial x velocity, which was at 10 cosine 30. So we got that times t. All right, well, I can't do anything with this yet. I have two unknowns, right? I have range, r, and then t. Both of those are unknown. So now let's go to the y direction. We're still going to go from A to C and see what we can do. So I'm going to use the same equation, but for the y direction now. All right, and this one, ay, does not go to 0, so I have to keep this last term here. Okay, so for this one, the final y displacement will be yc, so that's 0. The initial y displacement was ya, so that's 0, plus my initial velocity, so that's 10 sine 30 times t. Then finally I end up with this plus 1/2 negative 9.81 times t squared. Now if you do the math, you'll move this term here over to the left. It'll become negative, so the negatives will cancel. One of the t's here will cancel, and then you can solve for t. All right, so basically we're going to have 10 sine 30 t equals 4.905 t squared, but this t and this t cancel. So then the time from A to C is going to be 1.02 seconds. All right, so that's how long it takes for the ball to travel from A to C. Now with this time, I can plug that in right here and get R. So let's plug that in there. And then R is going to basically be 10 cosine 30, which is 8.66, times 1.02, which is 8.828 meters. All right, so that will be our range. Okay, so we got the first part done. Now we need to find the velocity at C. Okay, well there's not much else I can do here from A to C, so now let's look at some different equations. So now let's look at our velocity equations. Okay, so let's use this one. So VC squared is going to equal your initial velocity squared. So let's just say that that's in the y direction. Actually, let's make a y here. VCy squared equals VAy squared plus 2ay times the difference in the y displacements. All right, and I think just a second ago I said we weren't going to do A to C anymore, but let's use this equation. All right, and see what we get here. All right, so let's leave this left side alone because actually I want to solve for VCy. That'll give me my y component of the velocity at C. And then VAy, we already said was 10 sine 30. We're going to square that plus 2 times AY, which is negative 9.81. And then I want the difference in displacement, which that's going to be 0 minus 0. All right, so VCy is going to be 5 meters per second. All right, so now we got that. And then we'll do the same equation for the x direction. You don't really get a whole lot out of it, but let's write it out anyways. So if I have VCx squared equals VAx squared plus 2ax times xc minus xa, this term here goes away. So your final x component of velocity equals the initial x component of velocity. All right, so not a whole lot to do here. So that's going to be 10 cosine 30. All right, so VCx will be, will be 8.66. So now I've got my x component and my y component of velocity. And if I want to find the magnitude, we just do the square root of the sum of the squares. So we'll do 8.66 squared plus 5 squared. So then VC will be 10 meters per second squared. All right. And there's that one. All right. So that was what you were asked to find. All right. And it says H on the diagram. So let's go ahead and see how we work through and find that. All right, so if we scroll back up here and look at our picture, we want to find this value H. All right, now this is at point B. That's that max height. Now remember what happens with a projectile. So if we have one, it's going to go up. It hits a point where the velocity goes to 0, and then it's going to fall back down. So at this point B, our velocity is going to go to 0, velocity in that y direction. So let's go ahead and look at our equation. So let's do VBy squared equals VAy squared plus 2 times AY times the difference in the displacements in the y direction. So yb minus ya. All right, now we already said that the velocity of b is going to go to 0 because it's going to go up, stop, and then it falls back down. So here, this is going to go to 0. VAY, we already said, was 10 sine 30. We want to square that. And then we're going to have plus 2 times negative 9.81. And then YB is going to be H. And then YA is 0. All right, so if you simplify all of that and we take this 10 sine 30 squared, move it over, we're going to get 25. That'll be negative, equals negative 19.62 H. All right, so H then, once you solve, is 1.27 meters. Okay, so that gives that max height that that ball reaches at point B. All right, so that's the end of that problem. And hopefully that explains how we went through and worked all the different steps. All right, guys, I will see you all next time.